if you take a look at your graph for the second one, see if it looks anything like mine. You do run out of space, so just give it the best you can. We had to have a vertex at 0, 4, and then you're trying to go up 3 over 1, so we just ran out of one box. So did you make a graph like mine? You did? Good. So walk me through 3. Where would my vertex be? 0, 2. Perfect. And then the slope of the right-hand branch would be -2. So I just go down 2 over 1, and then I go down 2 back 1 for the other side. That's it. Did you make that graph? Oh my gosh. One more. Where is the vertex? And it's going to be a positive 4, 0. Right? Because you always want the opposite of that number, comma, that one. So that's a 0. So 4, 0, and then my slope is 3. So up 3, to the right 1. Up 3, back 1. So I should have that. Real quick, let's talk domain and range. What's domain of this graph? All reals, always. And the range? Greater than or equal to 0. Perfect. Oh, sorry. All right, now, if you take a look at number 5, 5 is the first one that doesn't fit the form that we've been talking about, right? So if you remember what that form looks like, it was y equals a, x minus h plus k. We haven't had something in front of the x before, but now I do. How to handle it? Well, basically, we're going to extract that number. And here's how we're going to do it. I need some paper here. All right, I've got y equals negative absolute value of 3x plus 3. All right, so there is a property of absolute value that says if I have multiplication in here, what I can do is I could split them up. So instead of, I can do this. I can take the absolute value of 3 times the absolute value of x and split it up like that. Do you follow me? No, okay, hold on. Let me make up some numbers. Let's say I had, let's say I wanted to do the absolute value of negative 2 times 3. We know that that answer is 6, right? Yeah, because you would multiply first and then take the absolute value, right? So the answer to that is 6. So this property of absolute values lets you, as long as it's multiplication, I can take the absolute value of each number separately and still get the same answer. What's the absolute value of negative 2? 2, and the absolute value of 3 is, so 2 times 3 is still going to get me a 6. Do you follow? I don't even need these absolute value bars because if I take the absolute value of that and that, it's already going to be positive. Will this always work? Yes, as long as it's multiplication. Think about it. Even if it was 2 negatives you were multiplying together. Negative 2 times negative 3. That comes out as a positive 6, right? Would it make any difference if I took each one's absolute value separately and then multiplied them? No, as long as it's multiplication. If it's addition or subtraction, the property doesn't hold. Okay, so what I can do if I'm taking the absolute value of a product is I can take the absolute value of each one individually. So essentially that's what I'm going to do here. I'm going to take the absolute value of 3. I don't know why I keep drawing these. I don't need them. So I'm going to split that up into the absolute value of 3 and the absolute value of x. What is the absolute value of 3? 3. There is this negative that's on the outside, though, and that stays. So now, when I graph that, it's the same thing. You with me so far? Mm-hmm. But, and here's what messes a lot of kids up, is because if, say, my original had looked like this, y equals negative, and then it was negative 3x in there, it ends up being the same thing. Because if I split this up, y equals, that negative is still there, absolute value of negative 3 times absolute value of x. The absolute value of negative 3 is still 3. So I still get this. Sorry. See how they're the same, even though that 3 was a positive and this 3 is a negative, it doesn't matter. Because I'm taking its absolute value. Isn't the absolute value of 3 and negative 3 the same thing? So that's why it makes sense, even though they were positive and negative, once I pull out that 3, they're going to match. And now it's in the form that I'm used to graphing. So now I can graph this one all day long. I'm going to have a vertex at 0, 3, and then the slope of the right-hand branch is just negative 3. All right, so what do we say? 0, 3, and then the slope is negative 3. This does get a teensy bit harder, but let's try another one that doesn't get too hard yet. Let's skip to 7. So your shortcut is to just take the absolute value of that number and put it on the outside. But the reason why I'm allowed to do it is because I'm really splitting that absolute value up. It's just multiplication there, so I can split it up into the absolute value of 2 times the absolute value of x plus 4. Well, the absolute value of 2 is just 2, so I've arrived there. And now I can graph that. Okay, you graphed it? Where's my vertex? Ooh, I just heard someone whisper it. 0, 4, whisper. I whispered it along the breeze. And then a slope of 2, so I go up 2. And there we go. Did you make a graph like that? All right, let's see how you think you're going to handle number 9. It's the same idea. So you're really going to get y equals what? 4 absolute value of x minus 2. Does everybody see where that's coming from? You're going to take the absolute value of 2, which is 2, and multiply it by the 2 that's already there. So now I've got the absolute, y equals 4, absolute value of x, and then the minus 2. And now it's in the form, and I can graph it all day long. So this thing's vertex would be at why, yes, 0, negative 2 is correct. Great job. And then its slope would be at, or its slope would be 4. So from that point, I would go up 4 to the right one. I notice how we were talking about the bigger A is, the more narrow it gets. So if you compare, there's an A value of 4, right? If you compare that to some, like on the other side we had 2, on our other paper we had 1s, right? See how much more narrow that graph is than when A is 1? Okay, one more for you to try, and then we'll do the hardest that they could possibly get. Try 12. Everybody try 12. Okay, so we're going to split this up. Absolute value of 2 is 2, and you're going to multiply by what's already there. So your equation is y equals what? Negative 4. Absolute value of x minus 2. And then hopefully once you have it in this form, you can quickly graph it at 0, negative 2, and then with a slope of negative 4. All right, so that's medium level, I'd say. We did easy, medium. You ready for hard? Well, you know what, too? I'm going to give 2 versions of hard. There's hard level 1, and then there's hard level 2. Yes, but I think first we should do 10. 10 is hard level 1, in my opinion. And then the rest are hard level 2s. But don't worry, once you get the hang of it, you'll be like, oh yeah, that makes sense. Okay, let's look at 10. 10, by golly, I have a problem now. I don't just have multiplication in here. I can't just split that up willy-nilly. What I can do is I can rewrite this. Okay, watch this magic. Are you watching? Are you paying close attention? Are your eyes glued to the screen? You ready here? I can rewrite this as the product of 2 things. Yeah, what times x plus 1? 2. 2 times x plus 1. Can I do that? Can I factor out a 2? Yeah, that's exactly what I'm going to do. Check this out. 2 times x plus 1. So all I've done so far was I factored a 2 out of there. Now I get to do that cool little trick. So now I'm going to split them up. The absolute value of 2 times the absolute value of x plus 1. Absolute value of 2, absolute value of x plus 1. And now I just get the absolute value of 2 is 2 times 3. Look at this. Hot dog. Oops. That's supposed to be a minus. Isn't that the form that we know how to graph? Yes. So you have your vertex at -1, comma -2. And then the slope of the right-hand branch is just a 6. So let's try that. -1, -2. And then the slope, what did I say? Positive 6? Yep. So up 1, 2, 3, 4, 5, 6. Ooh, that's a steep one. We don't have one like this on the paper, but let's just see if we can rewrite it from an equation that looks like this to one that we could graph. Let's just try this one. I'm going to make it up for you. Y equals negative 3 absolute value 4x plus 8 minus 7. Rewrite that into a graphable absolute value equation. I'll let you, let's see, I'll leave that one up on the screen too so you can follow the same steps. Did you get it? Go ahead.
Negative 12 offset by x plus 4 minus 7.
Oh, you're so close. The 4 shouldn't be a 4 though. It should be a 2. Yes. Perfect. So we are going to factor out a 4, and you'd have x plus 2 left in there. And then I'm just going to take the absolute value of 4 and the absolute value of x plus 2 separately. The absolute value of 4 is just 4, and 4 times negative 3 gets me negative 12. X plus 2 is still in there, and then the minus 7. So now if I wanted to graph that, I could. Yeah? Okay, so we're going to leave the hard level 2 for after vacation. I think you guys have done enough today.